So now we can plug this the result of this node inside this for each. And before we compile everything, so before we make this for loop run over each of the pieces, there is an option here that says multi-thread when compiled, and we will turn this on. But in order for this to work, we have to set up a compiled block. And in order to do this, we have to encapsulate all of these nodes that we bring outside of the loop. So we can see that this is currently how this is being encapsulated, marked by this orange border over here. And we have to make sure that everything we bring inside this loop is also being encapsulated. So over here, I will drop down first a block begin. And I will set the block path for this to be our for each end. And we can see that it starts to cook, but I will press escape on this and I will set this to manual update because we don't want to cook this node until we set up all of our blocks. Okay, so from here we want the method to be fetch input, and we will copy this node by holding Alt, and we also want to place our object merge inside a block begin and also place our third cutter inside this block begin as well. Alright, so all of these should have the method set to fetch input. So now further we can encapsulate all of these inside a compiled block. And I'll go ahead and maybe grab all of these and drag these over just a little bit, and I will place a block begin compile over here. And from this node we will drop a block end compile. Okay, and let's make sure that our compile begin has the block path set to our block end compile node. And now all we have to do is copy this node before each of our block begin nodes. Okay, so I'll copy this over here, and we can see how now we are encapsulating all of this inside a compile block. And also, also let's copy this over here. Okay, so now these nodes that we are bringing inside the loop will not have to be recompiled every time this runs, and we can use this option on our for each end, which says multi-thread when compiled. So what this basically means is that each time we run this for each loop will run over a different processor on your hardware. And so if you have a CPU with multiple processors, which you probably have, this will make our block run a lot faster. So also from here I will drop down a null and I will set this to be fracture geo, and I'll set the display to this fracture geo. Let's make sure that we turn off single pass for our for each node, and let's preview this fracture geo and set this back to manual. So now we can cook this node and see the result that we get. So this should take a few minutes depending on what kind of CPU you're running, and this will be the result so far. Okay, so from here I can drop down an exploded view and we can view all of our pieces. Okay, so we can see that we have a lot of variation. We have a lot of large pieces, medium pieces, and a lot of small pieces as well. Okay, so this should be sufficient to give us an interesting look on our explosion. Let's go ahead and cache this result now. So I'll drop down a file cache after our compile node. Let's turn off version and type dependent cache. Let's choose a folder, and I'll rename this to initial fracture, and I'll save to disk. And I'll disable this visualization for now, and from here I will drop down an exploded view so we can visualize our pieces. Okay, so here we have them, and we can see that these don't have normals on the interior, and we can easily fix that if I drop down a normal node and I set the normal to be on the group that's called inside. And now back to my exploded view, we can see that the insides have normals as well.